Hello, everyone.
Hello.
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 Okay, great. It looks like everyone's here now. So I think the format is, I think Dr. Sommer will say a few remarks for An-Najah and hopefully Dr. Melissa as well. And then we're gonna have the first presentation with Maysam, Ashraf, and Anhaya. About 10 minutes maximum, followed by questions. And then the second group, Ahmed, Hiba, and Atta, followed by questions.
How long do we have for our presentation?
Is 10 minutes okay?
10 minutes?
Is that enough time for you?
Okay, we'll try.
If it goes a little over, it's fine.
Okay.
10 to 15 minutes.
Okay, so should we start?
Yes.
Okay, first of all, on behalf of An-Najah University and the fact my colleagues are for this wonderful opportunity to collaborate, learn, and also making all this our rank.
I'm so sorry, Dr. Sommer. I think you're breaking out. Do you have a way to get better connection?
And our students.
I think he's having an issue, a technical issue or a connection issue. I'm not sure. Just checking because he's out of Zoom now.
Yeah, he got dropped.
That's fine. I think if like when he's back, he could just.
Okay, I'm back.
Oh, yes.
Sorry for the interruption.
Go, Samir, please. Yes.
So basically, I would like to thank everyone who has been involved with this. Thank you, and I hope we continue this collaboration. We can see it's been a fruitful one, and I hope we can go on for the next cohorts and semesters. Thank you again. Thank you.
Yes, thank you. This has been a very beneficial partnership for both parties, I believe. I'm very excited that we were able to continue this semester. And I feel like each semester we learn, better practices and hopefully can continue to grow this in the coming years. So I'm very excited to see the final projects today. And thank you, everyone.
Thank you.
Go ahead.
Hello, everyone, and thank you for attending. I would especially thank the professors from Clemson University and from An-Najah University for attending, and I hope that you will enjoy our presentation. My name is Haya Mikawi, and my colleagues are Maysam Musa and Ashraf Habruman. The three of us are computer engineering students at An-Najah University, and today we are presenting our final project for Clemson Creative Inquiry in machine learning, which is heart failure prediction. Of course, I would like to thank Clemson University for this creative inquiry, and I would like to thank An-Najah University for always keeping us involved in such opportunities. Okay, next slide. Okay, so what are we going to be talking about? At first, we will take a look at problem statement, and then we will see the exploratory data analysis. We will see what tools did we use to visualize our data for the numerical features, categorical features, and for the target variable. And according to these analyses, we will see what have we done in pre-processing, and one more time, what have we done for categorical features and numerical features. And then we will go through the models that we have used and the results that we have got. So we basically used 4 different models. At first, we used logistic regression, and then we tried KNN, and then super vector machine, and support vector machine, sorry, and finally random forest. And then we have the conclusion, possible flaws and suggested ideas, appendices, and finally we will open the doors for discussion. So please feel free to take notes throughout the presentation so that we can discuss them at the end. Okay. Okay, the problem statement, as I mentioned earlier, it's heart failure prediction. Okay, so studies show that cardiovascular diseases are the #1 cause of death globally. 17.9 million lives each year are lost because of them, which forms 31% of all deaths around the world. 4 out of 5 cardiovascular disease deaths are due to heart attack and strokes, and 1/3 of these deaths occur prematurely in people under 70 years of age. So imagine how many lives could be saved if we have a model that could predict heart failure or heart diseases before they happen for people with cardiovascular diseases or who are at high cardiovascular risk. So here comes the importance of our model for early detection and management. So we started with exploratory data analysis. And our data set consisted of 918 records and 12 columns. 11 of them are features and 1 target variable, which is heart disease. And these features could be splitted into 5 numerical features and 6 categorical features. The numerical features are age, resting blood pressure, cholesterol, maximum heart rate, and old beak. And the categorical features are 6, chest pain type, fasting blood sugar, resting ECG, exercise angina, and ST slope. And we didn't have any null values. So for simplicity, we splitted our data set into numerical features and categorical features, and we started the analysis for numerical features. So we started plotting the correlation between these numerical features to check for any dependency. And we actually found some kind of dependency between some pairs of numerical features. For example, there is some high correlation values between age and maximum heart rate, age and old beak, age and resting blood pressure, and maximum heart rate and cholesterol. Okay. Then we used bear plot one more time to visualize the dependency between these numerical features. And for example, we can clearly see that the high correlation between age and maximum heart rate. The diagonal shows the distribution for these numerical features, and we can see that they are almost normally distributed, but we have some kind of skewness in cholesterol and old beak. So from this analysis, we took a note that there is some kind of dependency between some pairs of these features, and we will see how did we deal with this when we started working. And then for the categorical features, we visualized different categorical features and their frequencies. So for example, sex, we have 725 males, 193 females. Chest pain type, we have 4 different chest pain types, and we can see their distributions. Fasting blood sugar, actually one stands for people with fasting blood sugar more than 120 grams per deciliter, and 0 stands for people with fasting blood sugar less than 120 grams per deciliter. Resting ECG, we also have 3 classes, and we can see their distribution. And exercise angina, actually 547 people didn't have exercise-induced angina. 371 people actually had exercise-induced angina. And finally, ST slope, there are 3 different classes, flat, up, and down, and we can see their frequencies. And finally, our target variable, which is heart disease. 508 records were for people who had heart disease. 410 records were normal. And from the figure, we can see that the two classes are balanced, which led us to a conclusion, which is that we can use accuracy as a good evaluation metric for the models that we are going to use. Now I will leave you with my colleague Ashraf to tell us more about pre-processing. Thank you.
Okay, for pre-processing part, we have categorical features and numerical features. So let's start with categorical features. In categorical features, we have binary features and non-binary features. So for binary features, we use label encoder to transfer the features, and the figure right side show that we have the features binarized as zeros and ones. So next, for non-binary features, we have three features that is non-binary. So we have we use the get dummies functions, which do the same functionality for one hot encoder. So the features that we have here is as one hot encoder vector. So the second, third, and fourth, and fifth column here got from a features which is called chest bend type, and also for the next three types and the last columns, sorry. Okay, next. Okay, for numerical features, before we got transfer or scaling it, we have to present the descriptive statistical metric, and it shows that we have different means and different standard deviation for each feature and different ranges. So here, the standard scalar or standardization at all is a must. So no feature will get a high weight from another feature in the model. Okay, next. Awesome. Here we use standard scalar, which use basically mean and standard deviation to transfer each table in the features, and the data here in the figure shows the data after scaling it, and it shows small ranges and small numbers that will help the model to get better results. Okay, next, Mason. Okay, here we got the features processed, and it's ready to split and get the models. Okay, next, Mason. Okay, after processing is done, we split it into train and test, and we choose test set ratio to be 25%, and they will be chosen randomly. And the target variable, we use to shuffle, we use target, sorry about the sound. We use target variable to shuffle and get more certainty and better results. Okay, and we have here 688 records for training and 230 records for testing. And after shuffling and splitting them, we have in the training 376 heart disease and 312 normal cases. For testing, we have 132 heart disease and 98 normal cases, which have balancing at all. Mason, go ahead.
Thank you, Ashraf. Thank you, Haya. I'll take it from here. Okay. Just a reminder that we have some kind of multicollinearity in our numerical features. Here we are required to use some kind of penalization or regularization to add it to our cost function to penalize the coefficients for our model. We tried for different algorithms, which are logistic regression, KNN, support vector machine, and random forests. For our logistic regression, we tried different values for C to see which value gives us the highest accuracy or the best results. We tried C equals to 0.01, and we tried 0.1, 110, and 100. The following, the following figure here shows the confusion matrices for different C values and the results we got. Just a quick reminder about the confusion matrices to understand them. You can consider the x-axis, the y-axis here as the actual classes and the x-axis here as the predicted classes. And we are always seeking to have high values in the diagonal here and any other cell. In the confusion matrix, we are seeking a low value for it. So it means here that we have H3 record is classified correctly as class 0, and we have 113 record is classified correctly as class 1. The other is incorrectly classified. Okay, in this slide we are comparing the results we got for different C values in logistic regression. We can observe that for values equals to 1 and 10, we have the highest accuracies among the existing ones, and it equals to 0.865. This is for our first machine learning algorithm or model. Moving to the next one, which is KNN. Okay, KNN algorithm depends on only primary hyperparameter, which is K, and it represents or means the number of neighbors I'm going to look for when I'm going to predict. So for example, if I choose my K value as 5, then for example, if I have 3 of them classified as class 0 and the other is classified as class 1, then I'm going to classify or to predict myself, supposing I'm the record, as class 0 since 3 is greater than 2. Here the question comes, how can I find the optimal value of K? That can be done by trial and error, and this, in other words, it means ILPO method or ILPO technique. Okay, the figure here shows the result of ILPO method. The x-axis shows different values of K we tried, and the y-axis shows error rate. We are seeking for a value of K that has the lowest or a minimum error rate. We can observe here that for for values of K between 11 and 15, we have a stable and low error rate, and another stable region between 25 and 30. Here the values give a low error rate, and for our model, we chose K equals to 25 as the hyperparameter value. And the accuracy we got is 88%. And the following confusion matrix, we can see that 86 plus 118 were classified correctly. The other 12 plus 14, which is 26, were classified incorrectly. Okay, the next model is support vector machine. It's another linear model as logistic regression. We use different C values and we compare the results for them. And the figure here is the confusion matrices for the different C values. It's pretty clear that we have close results here. The first four models performed better than the last one. The figure here ensures what I said in the previous slide. When C equals to 100, it has the lowest accuracy among the existing. And when C equal to 1 and 10, we have the highest accuracy. Finally, our final model is random forest. What's so special about random forest is that it uses in simple learning, which is basically I'm not trying to to train one model. Instead, I'm trying to train multiple models in parallel. And that gives me a better predictive performance and a better results and avoiding overfitting. We tried different values of number of estimators that can be run in parallel. First, we tried the number of estimators to be 50, then 100, 150, and so on till we reach 450. And the following figure shows the confusion matrices for different number of estimators, different number of estimators that we run in random forest. Okay, the slide here shows the accuracies for different number of estimators run in parallel. We can see that when the number of estimators was 150, we had the highest accuracy among all models we used before. And when it equals to 200 and 350, it has a close or a close value of 90%. So it has also a high accuracy. Finally, our conclusion is that all our different four algorithms give same or similar results. Logistic regression and support vector machine, the linear models gave us results and an accuracy range of 0.85 to 0.86. Canaan and random forest gave us results and accuracy results in range of 0.87 to 0.9. Random forest was the best algorithm that gave us the highest accuracy, which is 90. This slide suggests possible flaws and ideas that can be used to take us to a further level of optimization. First, of course, if you have more data, we can optimize our models and the results. Second, in our pre-processing phase, we didn't take outliers in consideration, but doing that may lead to better accuracy results. Finally, we can use unsupervised techniques for improving our results by, for example, adding more features to our dataset that may have patterns and dependency with the target variable, so our model is improved further. In the appendices, we have two links. The first for our notebook we wrote, and it has all the code and the results. The second is the link for the dataset we took from Kaggle. It's discussion. Any questions? Can you hear me?
I don't have any questions, but I think you guys did a really good job. Yeah, no, I think you guys went through a lot of different types of machine learning. I guess I will ask, so you guys tended to use a lot of supervised learning techniques. Do you think that maybe that's part of the reason that your results are very similar, is because you're kind of using maybe those same types? Do you think that if you did like neural networks or something, you might get better results?
It could be, but maybe we will be facing the hyperparameter tuning. It's not easy to find the best hyperparameter values in in neural networks.
Very true.
But sometimes, for example, in simple models can do the job completely. They
Very
are
true.
powerful.
Okay, to be honest, first of all, I would love to thank Alia for this great action opportunity, and thank you for also giving the students the chance to be exposed also to international experience. So we're really blessed for this experience. And my question to you, Ashraf, first of all, I'm super proud of the presentation. You guys did a great work. The slides were very clean. You walked us through the whole journey that you did with this course, which was very clear again. So thank you so much for Clemson University, Dr. Melissa, and Michaela, thank you so much for also being part of this. My question to you, Ashraf, if you actually went back in time, what would you do differently in terms of actually dealing with the data? Is there something that you noticed, you and your team, of course, this question is for Ashraf, Haya, and Maysam. So is there something that you guys will do differently, and why? I just want to understand that part.
Please again the question.
Yeah, my question is, if we're starting this from the beginning one more time, so you're having the data, is there something that you're going to be doing differently from what you guys did? Will you add, for example, I think Michaela kind of asked it in a different way, but is there anything else that you would do with the data that you didn't apply up to now? Did you notice something while you've been working on the models that you wish that you did differently?
First, I believe we got good results. And yes, I would do some things differently. For example, I would like to try neural networks. It's not that hard, but we saw that supervised learning techniques is fair enough.
Okay, and maybe we have to use normalization techniques like transfer data from -1 to 1, or any kind of extract features, or maybe extract noise from the data. Yes.
Yeah, so I have, well, first of all, congratulations. Very, very good presentation. Enjoyed it very much. So I have one suggestion and one question. And Michaela probably knows what my one suggestion is going to be. One thing that we try to get students to do in their presentations that helps in this part of the presentation, the discussion part, is to put slide numbers on your slides. So that way, as I'm listening to your presentation, if I have a particular question that relates to a particular slide, I can tell you to quickly go back to that slide. So just kind of put that in mind as you continue your academics and into your career, that anytime you're giving a presentation, that's a good thing to do. My one question, I think it kind of follows on the previous two questions, is that did you consider maybe removing any of the features that maybe were not, correlate is not the right word, but that were not important in the prediction? Did you consider looking at that?
Yes, of course, we can apply that by hypothesis testing. We can eliminate a lot of unnecessary features.
So was that something that you tried or something that you might do in the future?
Yes, we can apply it in the future.
Or kind of using VCA, maybe it's useful.
Exactly. Very good.
So should we move to the next presentation, Adia?
Dr. Summer, or did you want to say anything, or? Okay, yeah, definitely. Thank you, everyone.
Thank you all.
Thank you.
Hello, everyone. I and my team, Ahmed and Hiba, would thank you, Dr. Melissa and Clemson, for taking this opportunity and giving us this opportunity. We thank Dr. Mona and Dr. Samer for following us and following up, and Alia. And we wish you a happy birthday, Dr. Mona. Today, I will leave you guys with Hiba to introduce the presentation.
Hello, everyone. I'm Hiba Habash. Now, I would also like to thank Clemson and Al-Najah University for this opportunity. And let's get started. Our project is facial emotion detection software. Before getting into the implementation and the process, let me tell you the reason why we chose this project in particular. We all know the importance of emotions in our life. It's an important thing for everyone. And we can tell the state of someone by looking at their face. So why not taking advantage of that or using that and implement it as a functionality in a software? We started out by forming the idea of how we can apply facial detection and how we can detect also emotion in the software. Now, we did some research and we distributed questionnaires to help us to see if it's useful to build this software or how we can use this software in the most efficient way. Now, our presentation will go by saying the learnings, the building process, and how we improve the training and the use cases. I'm going now to demonstrate the use cases of how we can actually benefit or use this software. Now, the first use case is we can use facial emotion detection in the gaming industry. Facial expression recognition can also be used in video games and testing face. We all know companies that build games test their games by giving it to some users and get their feedbacks or their behavior while they are playing that games. By using facial expression recognition, game developer can actually gain the insight immediately and draw conclusion whether the game is good or bad, or what this game targets, what emotions in its players. The other way, or the other case we can actually use this software that we built is behavioral testing, which is really important. Every company or every creator that built a product wants to get the honest or the genuine feedback of its users. We can give the software to them while the users experience or use their product, and it can make it very easy to capture the expression that can detect whether the users like the product or dislike this product. The last case we can use this software that we built is by doing market researches. Traditionally, market researches are done by conducting surveys, distributing forms and questionnaires, which consumes a lot of time and resources. We can use the facial expression recognition system by allowing companies to conduct market research and measure moment by moment, like immediate feedback of market users, and make it to aggregate this result by just analyzing what the consumers and customers feels. Now, the next step, we are going to demonstrate or explain how we started learning and how we started implementing. And my teammate Ahmed is going to take the presentation now.
Hi everyone, how are you? First of all, before we just going to build the model, actually I didn't invent the wheel in this model. I used some build models so I could take from them and improve in them. So first of all, Clemson put me in the road so I could go to other courses. I took 4 courses in deep learning and convolutional neural network to be able to understand and start an idea of how build something improved. Because this project, it's good. You could find it in YouTube and Udemy. But what we make in this project is that we improve the accuracy of our training. So first of all, we use Google Colab. So using Google Colab helped us to build our model, training and testing. We took the training and testing models in this and start to build it in our convolutional neural network. Actually, when we are building the convolutional neural network, the architecture of it, we using 4 layers. I discussed all about this in the report. It's the thesis, but I could conclude what was theirs. There was an input, 80 by 80 pixels, and the convolutional layer was 4 layers. We used ReLU layer, we used pool layer, and we used fully connected layer will process the class scores. And then after training and testing and taking the 3 files from Colab, the tensors, we took image processing course in the university. We are familiar with OpenCV. Then we did a lot of research about how to make a streaming. So we used a library, it's open source, built in C++, but we implemented it in Python, it's dlib. We took it, that helped us because our system is not just taking an image and recognizing it. It's not input and output, it's real-time something. Okay, video, it's a frame of images, but you must be familiar with there's going to be changes. Like if you imagined it in code, it will be like an infinite loop. While loop, there's a code block and it will count the frame every maybe half milliseconds or stuff like this. So in the 4th step, we built the model that can detect different expressions. Before this, we try to dig deeper to understand the detection of the face, because like this, you see my face, I have something in the background. I didn't like this something in the background, which is noise, to going inside my convolutional neural network, because it's going to make it like it's not robust or not efficient for this. So first of all, by using OpenCV and real time, we took the face expression, like we took it and we applied it to our convolutional neural network. Then after this, there's 2 phases training on our model, where we have frozen few layers before our model start overfitting. We are trying to split our phases to 12 epochs and then 8 epochs, so it could detect the overfitting and prevent it from happening. So after this, the 7th step, evaluating our model on test set and applied real-time prediction. This is the result of our model. Next slide. Okay, what we did different from others, actually, because it's in Kaggle challenge and there's an efficiency rate about 57% in the training, the accuracy. So what we did to improve this, first of all, we make detection of the face, we crop the face, and because if you have different structures of how the face it is, like it's bent like this, or it's zoomed or stuff like this. So we took all those cases in our model. Also, we have close crop faces in our datasets. They are very noisy, but filled out all images which were not detected by face detection algorithm. We can make our model more robust. Go to the next slide. Increase number of phases and decrease number of epochs per phase while training. This is could detect the overfitting and split the training in this phase, so we couldn't reach a point that there's an overfitting, like making our system like, if this do this, if this do this. This is not this is a stupid way of building an intelligent system. to understand what's your facial emotional recognition. And the other approach, we used another version of efficient net structure of the convolutional neural network. Instead of using B3 architecture, we used B7. It's used in a structure softmax activation function, so that it can be executed even lower hardware specifications, because we run it in our devices. So maybe if we want an organization to put the camera in front of a door, for example, to start detect the clients, how they feel about the organization or whatever like this, you didn't have a heavy hardware to understand and build your system on it. Now I leave you with Ata to complete.
So everyone, to summarize what Ahmed said, we should have a good knowledge of Python programming language, as the whole code would be written in Python. So we could use some libraries from Python like TensorFlow, NumPy, Matplot, and something like this. Secondly, in-depth knowledge over linear and logistic regression, because these are the bricks of neural networks. Thirdly, understanding of basic image processing. So we could process the images. So we can use the OpenCV libraries and such like that. And finally, basic understanding on artificial neural networks and convolutional neural networks working and implementation. Now, in the building process, firstly, dealing with image datasets. Our datasets are available in Kaggle. The dataset we use contains 48 by 48 pixel grayscale image of faces. Each face based on emotion that's shown in facial expression of one of the 7 categories: happy, sad, angry, disgust, fear, natural, and happy. So then we perform data processing and augmentation as and when required. So to process the data, we should use an suitable form of data to suit the TensorFlow. So we convert the image files to a tensor objects by decoding it. Then, as we notice that these images are 48 by 48, so we resize these images to 97 to meet the deep learning standards. Then we apply the augmentation data to, because our datasets are imbalanced, so that the number of happy images are different from the number of sad images. So to provide the overfitting, we apply the augmentation data. So we rotate, flipping, and zoom these images in a random way. Finally, we create and train this convolutional neural network with the TensorFlow. So as Ahmed mentioned, we create our model based on efficient net, and this model contains in a hidden layer 128 neurons with the ReLU activation function, and the output layer has 7 neurons with softmax activation function. Then after that, we divided our dataset to training, testing, and validation datasets by 80% for training, 10% for both validation and testing. And then we finally get our facial expression recognition system based on the 7th universal expressions, and we could apply this system with what Hiba said first at the beginning in these fields. And finally, meet our team, Hiba and Ahmed and Ata, me, and these some pictures we took from the program we used. We get these happy, surprised, angry, and thank you all.
Really good job, you guys. I think that was a great presentation, and I love the you know, real live testing at the end. So one question I do have is, you said that you ran it on your machines. And so one of the things that you're emphasizing is that you would like this to be a real-time machine or a real-time type software. So what type of hardware are you currently running it on? Like, was it your laptop? Was it like an edge device, like a Jetson?
Yes, for the processing to get the files of training and testing, we used Colab. It's better than Palmetto. I don't know, but yes, because our laptops didn't understand how making maybe I reached 25 epochs, then making 12 for Colab to collaborate with this. But yes, for the real-time system, it built in our laptops. Yes, okay. It's easy to use. You could make it for a mobile application, built on it a top module softwares. Actually, this system, we will use it in our graduation project in the Najah National University. So yes.
Very interesting, very interesting. So is this something that you could just like put on GitHub and then people could just download it and run it using their laptop camera?
Yes, yes, of course.
Actually, yes, we already pushed this project
GitHub,
on
yes.
GitHub, and we added you, and we
I
sent you.
giving you the permission. It's private, actually.
Perfect, perfect. I'll have to go check it out. Well, thank you guys.
Thank you.
Michaela knows that I love this kind of stuff. I want ideally in my classroom, there would be a camera at the front of the classroom facing the students, and then a screen that they can see and a screen that I can see in the back of the classroom, so that we don't have to imagine the question marks over their heads, or the aha moments, like it reveals that. So I'm always been fascinated by this kind of stuff, but very good job. I love the project. I don't really have any questions. My suggestion from the previous presentation stands. I did love the template of your presentation. I thought that was pretty cool. So great job, great job.
Thank you very much.
I loved it as well, and I kept actually trying it in my classroom. And I asked, like, because they did the presentation yesterday, and we were asking students to come and try it out, and it was super exciting. So I myself also don't have any questions, and I'm super proud of both presentations up to now.
Yeah, a few years ago, NVIDIA had a demonstration in their booth, and it was fascinating, all the people going by and doing different facial expressions, and adults all easily entertained by this kind of stuff. Adult geeks, I should say, easily entertained by this stuff. So very fun.
Actually, I used it for my family. Then they started to say it's going to reveal our feelings deep in our hearts. Then I said to them, no. But for a future work, maybe we could use voice, the tone of your voice, collaborated with the video and your hands moving and stuff like this for a future work to detect more, make more augmented reality about the system or this project.
Absolutely. No, I mean, there's tons of different things that you could add and continue to build to this. It's a really good base for a great project. And kind of like Dr. Mona was saying, I think it'd be very interesting, and like Dr. Smith, implementing it into a classroom, get some good like data sets, see how accurate it is, you could patent that. Yeah. I'm telling you, universities would buy that. But yeah, just to reiterate, it was really good to meet you guys this semester, and thank you guys so much for all of the hard work that you guys put in. I think your projects were great, your presentations were great, and I really hope that you guys continue on with the CI, but thank you so much for all the work that you guys have put in this semester.
Thank you, Dr. Makili, for everything. And thank you, Clemson and Najah National University. Thank you all.
Yes,
We're
thank you
super
all.
proud of you guys. We're super proud of, as
Yeah.
Michaela said, like your dedication, and because I think like Clemson already knows that they already taking courses, and this is like an extra course to a course they're already taking, and seeing all the motivation you guys are putting and the effort. I'm personally, I'm super proud of each single one of you.
Yeah, exactly. Thank you, Mona, for bringing this up. They managed to do all this given the course load they already have. So this is an excellent accomplishment. Thank you, guys. Thank you.
And not only that, just to reiterate the dedication, like they started at 6 p.m. today, but typically their like weekly meetings are much later. So they're meeting at 8 something at night. So I mean, they've really done a great job. So thank you guys so much. It's been such a pleasure having you guys.
You're welcome. But actually, it was really funny, and the topic is really interesting, and we have fun with taking these classes. Thank you all.
Great.
Well, I just have to give a little praise on Michaela as well. With my role as an associate dean, I get pulled oftentimes last minute, and I can always count on she's a steady ship in terms of mentoring these teams, both the students at Clemson and all of you. So big kudos to her on handling all of this semester. And I guess one last thing I just wanted to say is you don't have to tell me now. You don't have to send it to me directly, maybe it's through Aaliyah, but if there is any feedback, we welcome feedback. I can see from what you've done, what you've shared with us today, you had a lot of fun. Nothing ever works perfectly. I know we had a few hiccups at the beginning of the semester getting things set up, but we welcome the feedback, because what I said at the beginning, continuing to be partners in this and continuing to improve the experience and make it available to even more students. So I would welcome any feedback that you have in that regard.
Thank you so much. Yeah, thank you, Dr. Melissa, Dr. Michaela, everybody. And honestly, Dr. Melissa, thank you for continuing to work with us. You're the only creative inquiry professors who was even open to this. So the fact that you expanded it with us and are still open to it is such an amazing opportunity for our students. So we're really excited to continue working with you. And yes, we will share some surveys with everyone and also get your feedback and hopefully plan soon for next semester. We're really excited. Amazing.
Look forward to it.
Yep. And thank you, Aaliyah, for setting all of this up. You've been our coordinator for everything. So thank you again. But all right, well, congratulations, you guys. I hope the rest of your semester goes well. And I hope to see you guys in the future. So.
Great. Thank you, everyone.
Thanks, guys.
Goodbye, everyone.
Goodbye. Thank you all.
Thanks.